This is going to be a really short, really straightforward video. We're just going to introduce the idea and the process for finding the dot product of vectors. We're not going to talk about in this lesson what we use the dot product for. That will come in a later lesson. But for right now, we're just going to write down the formula and we're going to practice finding the dot product and other analytic things that we can do with the dot product. So we're going to define the dot product of two vectors. If I have vector u, which has horizontal component a sub 1 and vertical component b sub 1, and then I have vector v, horizontal component a sub 2, vertical component b sub 2, the dot product of those vectors, and it's denoted by u dot v, and the dot is pretty dark. It's bold, just like u and v are, so we know we're talking about the dot product of the two vectors u and v. It's defined by the product of the horizontal components plus the product of the vertical components. So you can see a sub 1 times a sub 2, horizontal components of u and v, plus b sub 1 times b sub 2. The dot product is really straightforward and easy to find. So to find the dot product of u and v, we multiply the corresponding components and we add them together. Note that the dot product is not another vector. It is a real number. You're going to have a real number here plus a real number here. So the dot product is a scalar. It is not another vector. So here, given vector u, which is 3, negative 2, and vector v, which is 4, 5, then u dot v, the dot product of u and v, is the horizontal components multiplied together, 3 times 4, plus the vertical components multiplied together, negative 2 times 5. So 12 minus 10, the dot product of u and v, is positive 2. We can also find the dot product given vectors in unit vector form as opposed to component form. So we know that a sub 1 would be 2, a sub 2 would be 5, b sub 1 would be positive 1, b sub 2 would be negative 6. So we can find the dot product u dot v here as well. It's 2 times 5 plus positive 1 times negative 6. So 10 minus 6, the dot product of u and v is positive 4. So here are the properties of the dot product. The dot product is commutative. If you're given two vectors, you're going to get the same dot product whether you take vector u times vector v or vector v times vector u. If we have a scalar change of one of the vectors and we multiply that vector by our scalar first and then take the dot product, we're going to get the same thing as multiplying that scalar by the resultant dot product. So we can take the dot product first and then multiply by the scalar, or we can take either one of those vectors that we're going to find the dot product of and multiply the scalar by one of those vectors. So that's multiplicative commutative as well. And then we can take the sum of two vectors and dot product it with a third vector, and this is the result. It would be the dot product of the first vector with this one plus the dot product of the second vector with this one. And that's because the dot product is full of multiplication. And the magnitude squared of any vector is equivalent to the dot product of that vector with itself. So that's just analytically how we find the dot product. Again, in a later lesson, we're going to talk about how we use that scalar, that real number value, with our vectors. But for now, we're just going to practice finding the dot product given two vectors. So that's it. Short, simple, sweet. Come to class next time and we'll find the dot product of vectors.